think we're live now. Hey everyone, thanks for tuning in for the workshop at the Cronos Hackathon. And today we're super grateful to have Lohann joining us from Enjin. Lohann is a senior blockchain engineer at Enjin. For those who are not familiar with Enjin, they've been around for a very, very long time, and before NFT becomes hot and sexy. Right now they have a full stack solution for NFT, going from the wallet, like more retail facing side of things, all the way to full stack tooling and infrastructure for developers. And Enjin is also known for being the creator of the advanced ERC 1155 NFT standard, which I believe Lohann will also give a good introduction about that as well. So yeah, Lohann, why don't you take it away?
Okay, thank you very much. So nice to meet you guys. So as Ela introduced, I am a senior blockchain engineer at Enjin. And today I would like to talk a little bit about the Enjin ecosystem, the tools that we have. And also I will present some tools that probably will help you guys with this hackathon and in the blockchain ecosystem as whole. So first, Ela did a very good introduction about Enjin, but just to go a little deeper on that, Enjin has been around since 2009, and the main focus at the beginning of the company was the gaming ecosystem, basically make it more easier for game developers to integrate their solutions or the games with the blockchain. So we create many solutions for that, like an SDK, some standards that are better suitable for games, and I will talk about them very briefly here. So in this presentation, I will talk about the Enjin platform, the Enjin wallet, the SDK, and a little bit about our infrastructure. And the most part of the presentation actually will be practical. I will show you guys how to use the ERC 1155. That's not as famous as ERC 20 and ERC 721 standard, but it's a very, very powerful standard. And I would like to show you guys all the capabilities that this token standard provides to us. And also show you guys how to use that with the Enjin SDK, if you have time for that. So moving forward, what is the Enjin platform? If you guys work with the blockchain, you guys will realize that's not trivial to integrate things with the blockchain. It's not, people are not very used to how that works. For example, we have transactions. Transactions have confirmations. We have to pay fees for that. If you, for example, also transactions can be reverted. So there is a lot of complexities that we need to manage in order to integrate, for example, with Ethereum. And if you want to integrate with other blockchains as well, there's other complexities for specific technologies that we want to integrate. In this presentation, we will focus on Ethereum and EVM because that's what the most famous one for games, and also is what Cronos is using, the background. The Cronos is a EVM-based blockchain. And another thing that basically Enjin is doing, instead of providing that very complex API where you need to, for example, manage the nonce of the user accounts, fees, and all that complexity, we provide a SDK for game developers. So basically, we abstract all this complexity for integrating your game with the blockchain, so the game developers can focus on their business rules or game logic. So another tool that Enjin provides is the Enjin wallet, which is a wallet that supports any NFT. If you guys are wondering why another wallet, because there's hundreds of thousands, actually hundreds wallets available. Enjin Wallet have some features that the other don't. For example, when it was released, not all wallets supported, for example, the ERC 721 and the ERC 1155 tokens. So that's another thing that Enjin Wallet provided. You support more standards than the regular wallets. And it's also possible to integrate your Enjin Wallet with the Enjin SDK directly. So if you want to use, for example, Enjin SDK, you need to create an Enjin Wallet in order to integrate that. So it's basically, it facilitates a lot the work of game developers. The other thing that Enjin is providing is the Jumpnet. Jumpnet is basically an Ethereum-based blockchain that will be forever free, so no fees at all. You guys can see details on how that works. There is this GNG token where you can use for basic same transaction. It's a Jumpnet, but it's basically it suppressed the barrier of the price of the current blockchain. For example, today I took a look at the Ethereum mainnet, and for doing a simple ERC 721 transfer, an NFT transfer, it's about $10 to $20 in today's price. So, word. And just very briefly, also in addition to that, Enjin is developing a parachain for the Polkadot network, which is also focused on NFTs. It is going to support smart contracts as well, but the difference is that it have a more granular optimization for NFTs. Things that basically you can think in the fintech like a blockchain built specifically for trading and making assets. Ooh. So also Enjin was very active in the open source and blockchain ecosystem. As example of that, Enjin CTO Vitek Handomsky create and propose the ERC 1155 token standard. The ERC 1155 token standard is a multi-token standard that, in short, it allows you to create multiple fungible and non-fungible tokens and manage them in the same smart contract. This standard is very important. It's basically a must-need for example, gaming. It actually, this standard was built because of needs of the game ecosystem, but it's also suitable for any other. It's not very specific for a game. It's very generic and can be used in any context, as I will show you guys later here. For example, this is the interface for the ERC 1155. So one thing that this standard supports that the other don't is, for example, batch transfers. So you can do batch transfers and you can verify the balance in batch. So if you have a game that you need to support multiple different currencies, you can check the balance and you can transfer them in batch, and it saves a lot of fees. It's way, way cheaper than you deploy, for example, 10 contracts for supporting multiple currencies. It's like orders of magnitude cheaper. And another thing that this starter have is this callback interface, basically, that allows third-party contracts to be notified. It's basically a hook. So when you transfer some tokens to a contract, for example, you don't need, for example, to do that in 2 transactions. You can do that in just 1 transaction and perform some operation in the recipient smart contract. If you, for example, use the ERC20 standard, a very common approach for transfer tokens to a smart contract is that you approve the smart contract address to move some funds, you approve some amount, then you call that smart contract. So you are performing 2 transactions. Using this approach, you can do everything in 1 transaction, and I'm going to show that to you guys. Now let's jump to the good part. I will do a quick demo to you guys about the ERC 1155 standard, and you're going to see how easy it is to integrate that. The ERC 721 standard is very stable right now. It's around for a long time, so it's very stable. It's even supported by the Open Zeppelin. For who doesn't know, Open Zeppelin is I think that's today's the most famous library for smart contracts. It's very robust. Everything here is audited, so it's very safe to use the contracts from this library. And also it saves a lot of time in development. Just to show you guys here how I will present that using Remix. So I'm using this version of Open Zeppelin library. Just let me zoom it a bit. Cool. So I will open a new Open Remix workspace here. So I have some contracts, and let me just close those things here. Great, awesome. You can import libraries from Open Zeppelin directly in Remix if you guys want. So I will show you guys here really quickly. So let's go to contracts folder, token, and here you guys can see the most stable token standard supported by Open Zeppelin. If it's on the Open Zeppelin, you know that's very stable. And we have the ERC20 here. That is the for fungible tokens. We have the ERC721 for non-fungible tokens. We have the ERC777 that have other capabilities for fungible tokens, and also the ERC1155 multi-token standard. Just to exemplify that very quickly, why this standard exists, I will get, for example, Minecraft as example. Let's see here. It's not that. Oops. Come on, autocomplete. Okay. There we go. So let's say that you are creating a game and you need to represent this data here. Actually, let me zoom it a bit here. Where you have many tokens, they belong to the same game, but they are, at the same time, they are unique, they are different class, but they are fungible at the same time. Using the regular, for example, ERC20, it means that you need to deploy hundreds of contracts in order to support that. And that's not a very optimized way to do that. And you also have uniques here in this game, for example. A really good standard for represent that is the 1155 because it allows you to represent all those items, for example, in the same contract. So let's see how that works. So I will grab this preset. That's the most straightforward way to integrate with the ERC 1155 because this already implements some very useful interface that we're going to use. For example, to allow us to mint a token and mint in batch, pause the contract, basically freeze and unfreeze the contract. So let's use that. So I just will copy this URL here, go back here. Let me zoom it also. And the only thing that you need to do here, I already did that because I was testing that before. You just need to import the GitHub page and remove the HTTPS prefix here. That's everything that you need for import library direct from Open Zeppelin Remix. So this I have, for example, a mush token, and this mush token have a preset here. It's implemented that preset. So the only thing that you need to provide as a parameter, the only thing that you need to customize is the prefix URL. Because one thing that this preset also supports is what we call metadata. So for example, you have a token, and this token you want to support some images on it. And blockchain is not a good place for storing large data. So we are going to store that off-chain. So a way to reference that is using, for example, a URL for that, a base URL for that. So that's the constructor, and let's try to compile this. And probably I doing something wrong here. I've forgotten just a typo here. And done. It's compiling, and all good. I have the multi token. Now I will deploy this contract here in Remix. For if you are not used to Remix, that's a very powerful tool for testing and developing smart contracts. So on deploy it, and here we can see some operations. Just to for you guys know, these operations here, like mint and batch, they does not belong to the ERC 1155 standard. You are able to customize that because each game or each context have its own monetary policy. For example, you can have, for example, a rule where all tokens, the supply is constant. All tokens are minted when you deploy the contract. You can have a way where, for example, you have an account that's allowed to mint. So this thing is not in this standard, and you are allowed to customize that. But because we're using a preset here, the account that deployed this contract is able to mint tokens. And just an example here, I will mint a token to this address here. So I will copy the number. I will paste that address here. So that's the account. And I will mint some tokens. So this is the recipient account. And that's the other parameter, the ID. This is how you are going to identify your token. You can provide any number as you want. It's a integer value. So just for example here, I'm going to use 1, 2, 3, 4 as ID. And here is the amount of tokens that I want to mint for this account. So this is the token ID. This is the amount. Let's mint 1,000. We have this data parameter. I will talk about that very briefly, but this is a very powerful feature of the ERC 1155 also. And transaction. Cool. So since that it was successfully minted, so how I check the balance? So we have this method here, the balance of, that one belongs to the ERC 1155 standard. So I just need to paste the account here and the token ID. In that case was 1, 2, 3, 4. And I have 1,000. If I use, for example, a different token ID, it's 0. If I use a different account, it's also going to return me 0. So it seems very simple, and it's because it's simple. Choose this standard. It's that simple as the ERC20 or any other standard. But because you have many tokens, you can have the ability to manage many tokens the same standard. You can save a lot of gas using this approach. So I will just mint here another token. So I just create a new one, and I probably you guys record when I say that you are able to support both fungible and non-fungible token this standard. That's because you can think in a NFT like a fungible token where the total supply is equal to 1, for example. So let's say that I'm going to create a new NFT here, and the amount will be 1. So we can consider that, for example, NFT. And that NFT, I will say that is the 1111, for example. transaction. And if I check the balance, have 1. So this is how you represent. And the ERC-1155 standard is not very opinionative on how you do that. But one very common way to, for example, represent NFTs and fungible token is using a prefix. So for example, if the first byte is 1, is an NFT. If it's 0, is a fungible token. So you can use byte masks to differentiate between NFTs and fungible tokens. So when you mint a new NFT, basically, if it has the same prefix, you can mint a new one and you just increment the last byte, for example. That's a very common approach in this standard. Okay, so now I would like to show you guys the other very powerful feature of the ERC-1155, that is the ERC-1155 receiver interface. Just to show you guys here. So we are on the contracts token ERC-1155 folder, and we have here in utils, we have this on ERC-1155 receiver interface. So that's the interface, and in short, it tells to the contract when you are allowed or not to transfer ERC-1155 tokens to a specific smart contract. Let's see how that works in details here. So remember when I told you that, for example, for ERC-20, for sending some tokens to a smart contract, you usually will require 2 transactions. One approve and another one for send the funds. That basically you call the contract and it's going to send the funds. In ERC-1155, you can do that in just 1 transaction, and I show it to you guys here how. So the first thing we need to import this thing here. You just copy the link again. I already did that here. Is that last one, and you import. Let me remove those things that we don't need here. So we have this ERC-1155 receiver interface. But before showing that, I will show the wrong way to do that. So yeah, this contract is implementing the ERC-1155 receiver contract. And we need to implement those 2 methods. This first one is, you can think like a callback. Every time that you transfer tokens to this contract from the multi-token, it's going to call this function. For single transfer, if you do a batch transfer, it's going to call this one here. So let's see how that works. So I will compile this contract. Awesome, it's compiled. And now I'm going to deploy this marketplace. Marketplace deployed. And you can see that this contract have no methods here. It's just a test. So we have the marketplace here. I'm going to copy the contract address. So there's a reference. It's deployed in this address. And I will try to mint some tokens to this address here. 1, 2, 3, 4. The amount of 100, for example. And I will already told you guys that this transaction is going to fail, and I will go to explain why. It fails, and it fails because another thing that the ERC-1155 receiver interface requires is you need to return a specific code here in order to succeed the operation. This is to avoid, for example, if you implement this interface, instead of returning a Boolean, it's more explicit to return a code, a magic number for that. So let's grab this number here we have on the ERC receiver. And that is this key cake here. That's how we calculate this number. And I think that is that one. So just put that here. And I'm going to deploy another marketplace. So again, let me do that for the other one as well. So where's that number? Here. Cool. Now this contract is ERC 1155 receiver compliant. So let's compile it, and let's deploy another marketplace. So now it's on a new address. I will replace this address, and I will try to transfer again. This mint, actually a mint is a transfer. You created the token and you transfer this token to this address. Because of that, it's going to trigger this thing as well. So, and great success, it's working. But the powerful thing that we did here is that we can do, for example, call some callbacks here. So just for example, just to show you guys that what we can do here. So let's see that this contract, we only want to allow the token 1, 2, 3, 4. We don't want to allow any other token to be transferred to this contract. So what we can do here is that first parameter here, let me copy the full name here, is the operator. The operator is who perform the operation, because if you see the ERC 1155 standard here, you have this safe transfer from here, but not always the owner of the token is who call this operation, because you have this approve here. So if I approve, if I have my funds, but I approve another account to do this transfer, the account who call the safe transfer from is the operator, and the from is the owner of the funds. So that's the difference between both. So the operator is who signed the transaction, and the from is the owner of the tokens. And one thing that I can do here, the first thing is, for example, verify that I just want to accept this ERC-1155 here from this address, for example. That's very common. For doing that, I just paste that here, and I compare. Actually, it's a require statement. I require that the message sender must be equal to this address. So this way, I guarantee that I only accept this ERC 1155 token. The other validation that I can do is, for example, I would just allow a specific token ID. So the one that we created before, which is the ID 1, 2, 3, 4, for example. Cool. That's all. Let me see if it's compiled, and I need to convert that into an address. Let's do it. And I have a unused variable here and message sender. Oh yeah, because now I check this state, I need to change that to view. Just Solidity 0.8 is a little more strict. And I think that's fine. Oh, good. Don't worry about those warnings. It's just because we're not using all variables here. And let's try again. Let's deploy another marketplace. Copy that address. And I will try to do another transfer. So first, I will change the ID here. The the token ID. So it fails because of this statement here. And it fails again, probably because the message sender, I'm using the wrong address for this contract. And yes, I am. My mistake, I'm sorry for that. Let me replace very quickly here to the right address. Okay, and let's try again. Here. So transfer the new marketplace address. And it fails again. Probably I'm doing some, oh yeah, I need to copy the new address of the new marketplace here. Okay, this is the balance, what I want to meet. And it succeeds. Sorry for the confusion here. And when I use the wrong ID, it fails. It's just to prove to you guys that we call this callback when you do this operation. And it's very powerful because, for example, let's say that you have some business rules where you want, for example, to exchange some tokens. For example, I want to change the game coin A by game coin B. You can do that atomically using the ERC 1155, and you save a lot of gas. You can do like batch operations, batch transfer. That's a lot of potential here. That's a very robust standard, and I hope that here it is going to help you guys on how to use that, and you can see how simple it's doing that. Okay, if you guys have questions about the ERC 1155, let me know. And also, probably I don't have time for that, but because I need more 30 minutes to present the Enjin SDK. But basically, the way that it works, I will show it to you guys here really quickly. Just let me lock my account. So the Enjin SDK is the tool that I told you guys earlier that basically is a very fancy interface for game developers build and create NFTs. So I will log in here. And that's how the interface looks like. You can create new projects here. You can create projects in the Ethereum mainnet. You can also use the Jumpnet, maybe other networks. I'm not sure about how many we support right now. And you just press here to create a new project. You need to fill some information here, for example, a Cronos project and some description. And it's very straightforward. You create the project. And the next step is that you need to link your wallet here. So basically you need to download the Enjin wallet. And just to show you guys here really quickly. Actually, it will not be, I cannot share my phone screen. But you just need to scan this QR code using the Enjin wallet. I'm doing that right now. You can't see because it's on my cell phone. And synchronize it, okay. Now when I refresh this page, that will be synchronized. That's my wallet. And basically it's a very fancy interface for create fungible tokens. You can specify here the token name, if it's a fungible or non-fungible token. You can specify the supply model, if it will be fixed, it will be settled, if it will be infinite or annual, basically the monetary policy for creating those tokens. And but the very interesting part here is how you integrate that with the game, for example. So we have a GraphQL interface here with a very high level method. So the user that integrate that, the game developer that integrate that, don't need to worry about nonce management, how to create a wallet, how to hold. For example, storing private keys is a very tricky thing, doing that securely. So Enjin Wallet also manage that for you. And yeah, it's pretty much that. There's a lot of stuff here. If I talk about everything here, we need more 2 hours. So I will leave to you guys that research and just show you guys how easy it is to create an account in Enjin SDK and start to play with the NFTs and tokens. And I hope that you see some solutions like that in this hackathon as well. Thank you very much. I will stop sharing my screen here. And thank you for the invite, Ella and Leslie.
Yeah, thank you so much, Lohann, for the super informative session. Yeah, we also have a few questions for you as well. I guess for, you know, recently we've also seen a lot of like PFP NFT projects also using 1155 standards. I guess like from your point of view, you know, what are some of the use cases that's more suitable for 1155 versus 721?
The ERC-1155 is more flexible because I showed that you can represent both fungible and non-fungible tokens. And also the other features, for example, like batch transfer. That's one thing that we don't have easily in the 721, for example. So basically you save, you have more flexibility and you save a lot of gas using 1155 compared to 721. The only downside right now is that the 1155 is not as supported for third-party wallets as the 721, but it's changing very quickly. People are migrating very quickly to 1155, even after OpenZeppelin support that.
Yeah, I think like from the user perspective, cost efficiency is like the most obvious one that we all have direct experience with. Cool. Yeah. Another question I have is, I know like, you know, you guys are also building on parachain and kind of having the vision of interoperable, you know, hub for NFT and also with the other, you know, blockchain ecosystem as well. I guess, you know, from your point of view, how do you see, you know, Enjin is going to play in the multi-chain world, you know, in the gaming and NFT space?
So because Enjin have that long relationship with the game developers and blockchain, it understands very deeply their needs. And one of them, for example, you have a game. You don't need to mint like 1 or 10. You need to mint sometimes millions of NFTs. You need to manage that a very high volume of NFTs. And this is right now is very difficult in the Ethereum, for example, because we have this transaction gas limit, not some flexibility for doing a very granular optimization. So that's the reason why the Enjin basically create the Affinity parachain, is to support that very high volume of transactions. I did a presentation yesterday on the Sub-Zero conference. It's a Substrate developer conference. And I was talking about that, exactly that issue. If you see the Vitalik Twitter, one of the co-founders of Ethereum, he said, we need to move NFTs to layer 2 to decrease the Ethereum gas fees because it's infeasible paying $20 for transfer NFT. That's because we need standards, we need tools that allow us to do that more efficiently. For example, for transferring a fungible token, if you transfer 10 or if you transfer 1 billion, there's no difference. But for NFTs, if you transfer 1 or if you transfer 1,000, there's a lot of difference in the gas that you can do that. So that's one of the reasons why we're building Infinity.
Great. Yeah. Leslie, I don't know if you have any question for Lohann.
Yeah, maybe just like some comments on some of those like blockchain-based games that I've been trying to play. One thing is like something you have already covered that, well, you would need to like approval, and there will be server transaction involved. And for example, if you want to take like one single move, then you would have to approve like one single transaction. And then also on the game item management, well, you don't want like 20 smart contract to represent like some particular items, and you want to transfer that, or you want to sell it on the marketplace, and that would be very, very complicated. So I think this approach on like 1155 will be definitely something very helpful for the game developers, and also the overall experience of the user as well. Yeah.
Yeah, I totally agree. And another point out, the advantage of this approach is that it prevents a lot of common attacks in Ethereum, like intrinsic attacks, because you can do this type of exchange and atomic swaps in a single transaction. It's way, way safer than doing that in 2 transactions. So yeah, you're totally right.
Great. Yeah. So, the Cronos team and crypto.org chain ecosystem, we're also very bullish on, the use of NFTs in gaming. And we've, invested a lot of resources in the NFT space as well. So yeah, very much looking forward to see, any developers out there building interesting NFTs and gaming applications on Cronos from this hackathon. And Enjin SDK will be a great tool for you guys to leverage. So with that, thank you so much, Lohann, for joining our session. And yeah, thanks for your time.
Thank you very much. It was my pleasure.